Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Welcome to the SEI Podcast, a production of Carnegie Mellon University Software Engineering Institute. My name is Suzanne Miller, and I'm a principal researcher in the SSD Software Solutions Division of the SEI. Today, I am joined by Gregory Touhill, director of our SEI CERT Division. Our topic of discussion today is how to identify and prevent the next SolarWinds attack, and we'll talk about what that is in case you don't know about that already, but most of us do. But first, a little bit about our guest. In addition to his role at the CERT Division, he's also an adjunct faculty member in CMU's Hines College. He's an author, a retired U.S. Air Force Brigadier General, and was a senior cybersecurity leader in the Department of Homeland Security. He was also the first Chief Information Security Officer of the U.S. federal government. Prior to his appointment as the head of the CERT Division, Greg served as president of Appgate Federal Group, a government-facing cybersecurity services firm. Welcome, Greg.
Hey, thank you for having me today.
Nice to talk to you again.
Absolutely. I'm looking forward to it.
So we previously talked about secure by design, secure by default as a strategy for the future of security. Today, we're here to talk about other things that are one of the reasons we need secure by design and secure by default. I do want to tell our audience that if you did not see that first podcast, I do recommend it. We will link to it in our transcript, and it gives a lot of background on some of the things that are going on currently related to trying to address these issues. But before we get into SolarWinds, which is a fascinating topic by any measure, tell us what you think is the best thing about your job here at the SEI.
Well, it's definitely got to be the people. And one of the things that's attractive to most everybody who comes here, either as a visitor or as an employee, is the mission. And our mission's great. Helping our government partners in the military and the federal civilian executive branch better defend national security, but also national prosperity. Mm-hmm. That's an attractive mission set, and it's something I've done throughout my professional life. And as we work with our different mission partners in the Department of Defense, Homeland Security, State, Treasury, all the different parts of the government that protect and defend the American people, that's a great mission that helps attract all sorts of talent here. But what really brought me here is having been a customer of the SEI in my military roles, in my roles at Homeland Security in the White House, it's always been the great people that we have here in executing that mission. And I love getting up from my desk and walking the halls, and I'm just amazed when I get to bump into the world's leading experts in these different disciplines that we have here. We have the world's greatest software engineering experts. We have folks who are creating the artificial intelligence engineering discipline. And here we have the cybersecurity birthplace with the CERT Division that I'm so fortunate to work with. Our team, not only in my technical division of CERT, but across the SEI and across the campus. This is a great place to continue to serve the nation, and one of the reasons why I wanted to be here.
And I will say, after being here over 20 years, the people keep me here as much as the mission. I mean, I'm with you in terms of the mission is what drew me here, but it's the people that keep you here.
Absolutely.
And so that's a great recruitment speech there. Thank you, Greg.
You're welcome.
All right, but today we're here to talk about SolarWinds, and we want to talk about the initial attack. SolarWinds is the name of a company, right? Mm-hmm. It's a company based in Texas, and at the time of the attack, they provided software to our federal government. In late 2020, news surfaced about a cyber attack that had already been underway for several months, so that's not good. The attack had reportedly compromised 250 government agencies, including the Treasury Department, the State Department, some of the ones you've already mentioned, as well as nuclear research labs. And in addition to data that was compromised, it resulted in financial losses of more than $90 million. So if you haven't heard of SolarWinds before, this is probably one of the most dangerous modern attacks on software and software-based businesses and agencies and government in the recent past. So what do we know about the origins of that attack, and how did it actually unfold?
Well, first of all, let's make it perfectly clear to our audience that SolarWinds as a company were the victims here.
Absolutely correct.
They were the victims of a well-conceived and well-executed attack on their software supply chain. And as you take a look at how America's economy, and actually the world's economy, has been increasingly IT-enabled, the SolarWinds product actually is one of the best products out there in providing visibility across enterprises. I personally, when I was the Chief Information Officer of U.S. Transcom, and before that Air Mobility Command, we were customers. And it was because they had a superior product in the marketplace. Adversaries that took a look at the capabilities of that particular software set said that same visibility that CIOs and businesses were leveraging, given by that product, could be tampered with for nefarious purposes. And they launched a very exquisite attack to go after the code for that company, and got inside the product development cycle. And with subtle tweaks in the code, they were able to gain access that gave them greater insight into the customers that were using that code base. It was detected by a third-party company, Mandiant, which is now owned by Google. And Mandiant, which is arguably the world's best cybersecurity incident response company, Mandiant itself was a SolarWinds customer and determined, hey, we're seeing aberrant behavior here. They raised the alarm. They worked with SolarWinds. They notified the government. They leveraged existing governance and oversight channels. And we had a widespread community of interest response to that breach. And it was wholly unsatisfactory in the results. But as you peel back the onion, we took a look at this as a highly sophisticated attacker who got inside that supply chain and took advantage of that for purposes that still are under speculation. But all software that's out there has a lesson to be learned, and as far as the development, the product fielding, the quality, and getting back to our previous message of secure by design and secure by default, that they can learn from the lessons learned in this SolarWinds attack, or perhaps it's better to say the attack on SolarWinds that affected all of us. And as we've taken a look at what can we learn as a community on this, that secure by design and secure by default approach to putting products into the marketplace is critically important. But there's a lot of other things that are out there. And from a CERT perspective, we're taking a look out and saying, okay, what else is out there that could be tampered with, that could be exploited? What other areas are not being guarded adequately to prevent something that could be exploited to the detriment of national security and national prosperity? And I think as you take a look at those approaches, it all will start with the secure by design and secure by default.
And I know in other podcasts, we've also talked about things like the acquisition security framework, which is directly aligned to deal with supply chain issues for organizations that may not be as sensitive to the risks that are posed by their supply chain. I mean, that what you said about everything being IT enabled. It's not just IT enabled by my IT, but it's by my first tier and second tier and third tier suppliers. And that's really where we got into where the attacker on SolarWinds was very clever in understanding that and in using that as a means of getting access to the primary targets. So
yeah, absolutely. And as you take a look, there's plenty of examples that go back many, many years. And for our audience, I'd recommend you can go on YouTube, for example, and type Rob Joyce, R-O-B is his first name, and then Joyce, J-O-Y-C-E, and then type 2016, and then the phrase USENIX. Rob spoke at a conference, at the Usenix conference in 2016, when he was the NSA's head of tailored access operations. And that organization, think of those as the top cyber hackers at the NSA. And he talked about the techniques, and procedures used by hackers. Very rarely do hackers use zero-day exploits or things that hadn't previously been disclosed.
Right.
Rather, what they do is they take advantage of weaknesses in the applications of patches, proper procedures, and such. So I recommend folks take a look at that great video that Rob outlines. Hey, here's how folks actually go, from a nation-state high-level hacker.
Yeah.
This is what they do. And that comes from, at the time, the nation's top hacker, on behalf of the United States.
And what this brings to mind, and we've mentioned this before, the secure by design, secure by default is not a bunch of technologies. It's really mostly human-based governance, processes, procedures that, as humans, when we become skilled at something, we tend to let go of some of the guardrails that we might have used when we were less competent because, I know how to do this. But we really have to emphasize that the discipline of software engineering is really about maintaining that discipline no matter how much we know, no matter if we're Rob Joyce or Suzanne Miller, who's not nearly as skilled as she used to be. But we have to make sure that that the human element, that's really what these attackers are taking advantage of.
Well, as you take a look at systems and my educational background includes a system management engineering background, same as you.
I know.
There we go. We take a look at it from the cybersecurity standpoint along three lines of effort. The first one is the software. We've got to make sure that the software is secure by design and secure by default. But we also are looking at the hardware and the provenance of the hardware. And let's not forget that the hardware is a collection, a repository of all sorts of different software spread out amongst many components. And then we also don't lose sight of the wetware, the human element.
Yep.
We all are walking computers with the most powerful computer ever invented. But together, all three, the software, the hardware, and the wetware, come together into a system. And as you were taking a look at security, you have to factor in all aspects of the system. And the wetware, the human element, creates the processes, the procedures, the priorities, and such that help make that system work in an optimum measure. And ultimately, what we are looking for is methods that are going to enhance the effectiveness, the efficiency, and the security of that system.
And that means we've got to make the humans effective and efficient as well as the software and the hardware.
We've got to engineer the whole system.
Yep. So I want to come back to SolarWinds for a minute because I'm sure some people are thinking, scary that this had been going on for several months. So what, if I have any suspicions, what should I be looking for that would help me understand what are the warning signs that there might be something? What did Mandiant identify that would be warning signs that something might be amiss in my supply chain, in the software that I'm using?
Well, I have not seen the full Mandiant report myself. However, I've gotten plenty of briefings and had many conversations with folks from Mandiant as well as within our community. You always look for aberration, something that is not expected. In Sesame Street, they'd say, one of these things is not like the other.
Yep.
And that's often where you see tipping and queuing is when you see some aberrations. Typically, in a maintenance role, you are looking for aberration as a sign of degradation of capabilities, something's going out of tolerance. You can often see through maintenance activities where something's drifting out of tolerance. It's usually a sign that you've got to do preventive maintenance, you've got to do a replacement. Sometimes you have to do an upgrade. In this particular case, Mandiant saw telemetry that was inconsistent with how the product was supposed to work.
Okay.
And that caused them to provide a much deeper analysis of what was causing this. And some of their researchers who noticed the fact that this was providing some telemetry that was unexpected, they dug down deeper. And what they found was disturbing and comparing to expected and some of the documentation that was out there. They were smart enough to react that, hey, this is not right. They raised the alarm. They got with their supplier and compared notes. Is this normal? And when the supplier said, no, it's not, then a much deeper investigation was initiated, and the call to the community went out. So as different folks are taking a look at their systems, they should have a really good feel for what's the expected behavior of their system, what's the expected behavior of their telemetry, continually monitoring their data. Security operations centers specialize in this and have a lot of automated tools to help them identify when things are out of tolerance. But a lot of us aren't necessarily software engineers or cybersecurity engineers. We do this with normal day-to-day living too. When you're driving your car, if your car's not in alignment, you can feel it pulling to the right or left.
Right.
If you've got a tire that's not having the proper tire pressure, you can rely on the tire pressure monitor, the TPM, which a lot of vehicles now have. But you can also do the visual. Hey, that tire looks a little low. I'm going to go check that. So similarly, as we are looking at these software-intensive systems, we have a lot of tools that are put into the software to help us monitor. But then we also have the human element that can help us go and monitor and look for aberrations.
And ultimately, that's what Mandiant, that was the thing they did. And I also want to highlight the fact that they didn't stay quiet about it, because that's one of the things that we know is a barrier for organizations. The embarrassment of people saying, oh, you've been hacked, has sometimes in the past led people to wait to make a statement about this. And Mandiant didn't wait. They went forward with it. And that's really the behavior that you need so that the community can be protected, because as we found out, Mandiant was not the only victim of this, as a primary target. There were 250 or more.
And there was not a lot of delay at all. Kevin Mandia, a fellow Pittsburgher, and airman, or former airman in Kevin's case. Kevin Mandia, as the CEO of Mandiant, stood up and he said, look, we've been breached. Here's how it happened. Kevin reiterated SolarWinds is a victim, Mandiant is a victim, and there's a lot more out there.
Yeah.
He showed bold leadership in an environment where many companies would say, oh, I don't want to identify a material weakness because it could adversely affect my stock price or the value
Right.
of my company. Mr. Mandiant stood up as a leader and said, we have a problem and it affects the whole community, the whole of our fabric. And that's the type of leadership we need throughout society. Is this, when you find a problem, you stand up, you own it, and you take immediate action to fix it. And Mandiant did a great job in standing up, identifying the problem, and took a leadership role in identifying how we can fix it together.
So we've already mentioned a couple of resources that are available to people to find out more about the general topic of supply chain risk to software, secure by design, secure by default if you're actually producing software. For organizations that may feel like they're a little bit behind the curve on this, what are some transition resources for building their competency to prevent their own, being like SolarWinds and being a victim of this kind of deep supply chain hack? What can we offer to them?
Well, you mentioned the acquisition security framework, which is what I think is step one. Mm-hmm. I think as you take a look at the great work of Dr. Carol Woody and Chris Alpers and a lot of our other researchers that have really taken a solid look at how we acquire goods and services and software development and such, creating that acquisition security framework, it's a great way of companies of all size, from the really large multinational companies all the way down to the small and medium businesses as well. And I think it's important for our audience to recognize that, sometimes you put out stuff that only applies to certain businesses of certain sizes, but I think the acquisition security framework scales really well all the way down to small and medium businesses as well. I recommend folks go to our website, sei.cmu.edu, and in the keyword, type ASF, or Acquisition Security Framework, and you'll see a wealth of information on the research regarding this, as well as some details on how you can, in your organization, tailor your decision-making to take a look at, here's this thing that you have to take a look at, this thing, this thing, this thing, this thing. And when you do that, you are evaluating risk every step along the way.
Yep.
You'll never get risk to zero, but you can manage it.
No.
And then further, you'll be making risk-informed decisions that will help you better protect not only your business, but your contributions to national security and national prosperity. That's one. There's other things that you can do, such as work with our mission partners at CISA and subscribe to CISA's alerts. And CISA, for those who don't know, is the Cybersecurity and Infrastructure Security Agency, or CISA. And you go to CISA.gov or CISA.dhs.gov. I think they resolve to the same site. And you can sign up for alerts so that if, in fact, something bad happens in the cyber neighborhood, we in the CERT Division at the Software Engineering Institute help provide information to CISA at DHS to kind of be the neighborhood watch captain for cybersecurity. Right. So, if we see something, we say something, and we encourage the citizens of the country, the companies of the country, to say something too. But if you're not subscribed to that Cyber Neighborhood Watch alerting system, then you're missing out, and you don't get the timely results that you need to better manage your risk. So I recommend folks visit the CISA website at cisa.gov and sign up for the alerts so that you can have a very timely alerting system. But one thing, too, is we help CISA in characterizing these different attacks with the so what. Here's the problem. here's what the potential impacts are, and here's what you can do. And I think CISA over time has done a really good job at providing actionable intelligence and information. There's still a long ways to go, but it's been doing a really good job, and we're really proud at the CERT Division here at SEI to be a major contributor to that conversation.
And we actually did have a conversation about CISA and its future and the ways that we're working together in another podcast, which we will reference in the transcript. Right. Just like we'll reference the acquisition security framework. I had a great conversation with Carol Woody and Chris Alberts about things related to that. So, okay, I think we've plumbed the depths of SolarWinds and sort of things that we can do to prevent that. But I know that you, as the director of CERT, have got lots of other things. So just give us a little preview of some of the things that you have in work that people may not already know about who are listening to the podcast.
Well, there's a couple of things. First of all, we've been taking a look at software security for years. We invented the discipline of cybersecurity engineering here at the Software Engineering Institute, and putting together those best practices and the lessons learned from attacks that we're seeing, not only with the supply chain attacks, but other attacks that are going on. The first thing that I'd like to highlight is the fact that it's important to know where your software came from, and making sure that your software, in fact, has that secure by design and secure by default capability in there. So one of the things that we've been involved in is the conversation on the software bills of material, and particularly from the standpoint of the security lens. And working with our colleagues in the Software Solutions Division, we're finding some best practices and sharing them widely as far as here's some of the best practices and understanding where your software came from, as well as gauging the risk of the software and the resilience of the software, and advising our mission partners in the government as to how to implement such things in the like the acquisition security framework to assess the material weaknesses or strengths of the software. And a software bill of materials, I think, is a really good thing. But how far down do you go on that?
Good question.
Particularly when it comes to open source software. And we can go back to incidents back in 2014 with like Shell Shock and Heartbleed, where old code suddenly had material weaknesses in them. We're finding hackers out there are finding that old is new again when it comes to hacking.
Yeah.
And a lot of alerts that have gone out in the past that said, well, patch this, patch that, or this has weaknesses here or there. We're finding that across the world and across the country, there's a lot of old system and a lot of old code that's still in operation.
Yeah. People are afraid to touch it because it's the people that built it are retired, and nobody knows what's going to happen. It works, right? That's what that. If it's not broke, don't fix it. But that gives an opening to people that are willing to break it.
Right, and as a lot of organizations have put these legacy systems in place, sometimes their attention gets drawn away to the newer systems that are out there and the newer software. And they're not necessarily paying attention to that old legacy code with the same level of security awareness as perhaps they are with the enterprise IT.
Sure.
So what's old is now new for a lot of hackers, and folks that have that legacy system out there are best advised to pay even closer attention to that. Two is we find that folks continue to have what I call target fixation on enterprise IT and aren't necessarily paying as much attention to their data that's at risk and exposed in operational technology, Internet of Things, industrial control systems, and I'll add to that the RF-enabled devices that they have, and some of the data that they have in third-party clouds. So, a lot of software as a service entities are custodians of your data that could be very valuable, and in the wrong hands could provide a great measure of risk to your organization. So one of the things that we at the CERT Division here at the Software Engineering Institute, we're trying to raise the awareness for your entire cyber ecosystem and the protection of your data wherever it resides. And getting folks to understand that the operational technology, and a great example of operational technology are critical manufacturing devices, for example. Everything's computerized now. There's a measure of automation in all sorts of systems. So your operational technology, if you're in the military, an F-35 is a computer system with wings.
Yes,
it's actually many computer systems with wings. An M1A2 Abrams main battle tank, many computer systems with treads. Same thing with our ships and our submarines. But in the business world, you have numerous devices that aren't necessarily desktop computers.
Right.
You got to be thinking operational technology, your industrial control systems, those pumps, valves, switches, everything that keeps the lights on, the water flowing, Internet of Things devices, RF devices, software as a service, hybrid clouds, all of that. The attack surface is wider. Your attention needs to be wider. And understanding your risk with all the data that's out there is important. And then the third thing is think what's hidden and what's your risk with some of those things that are hidden to you. And one of the things that our researchers are doing is taking a look at a system that's called the Unified Extensible Firmware Interface, or UEFI. Many folks are familiar with the basic input-output system, or BIOS. As you go and you turn on your computer, it goes through the boot-up sequence. Well, over the years, we've kind of retired as a technology community the traditional BIOS that many of us grew up with and have moved over to a much more powerful system called UEFI. Well, that's all under the hood, as it were. It's, not only on the firmware, but in a partition of the boot disk, and it's very powerful, and it's also, in some cases, very vulnerable if you don't understand how things work and why. And our team has been taking a look at this as perhaps another attack vector, much like SolarWinds was. But we have, SolarWinds had a finite number of customers. So we take a look at, let's just say, Windows-based computers. 286 million PCs were sold last year in FY22, or calendar year 22. That's a pretty rich attack surface area compared, and you take a look at all the other that are out there that are pre-existing Windows-based systems. What's the possibility that a small nugget of code in that UEFI boot stack has been tampered with? And oh, by the way, each vendor has their own custom set. There's a very limited amount of folks who actually write the code for UEFI, but each vendor goes and modifies that stack, and there's usually 50 to 100 different permutations on each and every device that's out there. And traditional cybersecurity tools don't monitor, don't check that, won't even see it as it goes through the boot cycle. So we just hosted at this year's RSA conference in San Francisco a discussion for vendors saying, okay, here's the research that we're doing now, and here's some of the things that we are doing with the community. Because one of the things that we do is, as our background at the CERT Division has, is leadership within the cybersecurity community. So at RSA, we had 150 different vendors, attend this session. A couple of hundred folks, either in person or online. And we walked through, here's some of the things that we are discovering, but further, here's the community that we've built to go collaborate on the research for this. There's a lot of work to be done, but we're finding areas where we have recommendations for improvement so that as new products are coming in and those vendors are doing their modifications to their code for those boot sequences, that secure by design and secure by default is built in from the beginning, as opposed to just worrying, can I make this thing work? Regardless of the security posture. And we got great feedback at RSA for the work that Vijay Sarvapelli, Drew Kampanik, Corey Cohen, Jeff Gennari, and the whole threat analysis directorate have been doing in identifying this issue, helping folks prioritize that, and moreover, providing practical advice on how to make it better.
Excellent. And that's how you prevent the next SolarWinds, is get ahead of it.
There's other things out there, but I think that one is one right now in our headlights. And I'm really proud of our team for leaning forward and, like Kevin Mandia, raising the alarm, saying, we've got a problem here. Let's fix it as a community.
Okay, one more thing for me to worry about is whether my boot up sequence on my old computer is a UEFI or a BIOS.
Well, the thing about it is there's some things, very prudent things that you can do to keep an eye on your systems. First of all, if you do have an older system, and I think you don't throw away something that works, but you have to make sure that your defenses are up to date. And I, for one, am not unusual where I have an older system that has elements of it that are no longer supported. So I have, in fact, recapitalized on my home system, and I have a much more modern system that I use for most of my day-to-day internet-connected activities. But that elderly system, it still has a function for me. So I have disconnected operations that I do for management of finances, storage of passwords, and all sorts of stuff, but I've deliberately disconnected from the internet. I'm finding that I'm not alone. There's a lot of folks who have balanced risk and reward and have said, well, if the risk of connecting to the internet is high, I'm going to disconnect. Now, I'm also very prudent because I know that you can jump back and forth using different devices and such, and I take precautions there because there are methods to attack disconnected things. But it's all a risk and reward calculus. For those folks that are, in fact, requiring connection to the internet, do make sure that you're patched. Make sure that your hardware is up to date and is able to run the new, more powerful software that's coming out every day. Be a discerning customer, too. Make sure that you are doing your homework and buying systems that meet your need and have the flexibility to grow to your future needs as well. Don't spend more than you really have to, but make sure that you spend wisely and what you really need to based on the value of your work and the data that you have. Also, a lot of folks, they think recapitalization of hardware and software, but they don't think about recapitalization of the wetware. You need to make sure that you yourself are properly trained to properly operate the systems that you're using. And if you're a supervisor, if you're a leader of an organization, you need to make sure that as you are doing your budget, you are factoring in recapitalization of the wetware with training and making sure that folks are, in fact, well-trained and optimized so that the overall result is an effective, an efficient, and a secure operation. And there's plenty of ways to do that. And folks come to us all the time and ask us for recommendations on how to recapitalize the wetware through training and certification as well.
Yep, and I know for many of us that work in the government, we have annual updates to all of that kind of training, which is wise because there's always new stuff that is coming out, and I'll be waiting to see sort of some of the new things coming out as time goes on. I actually have observed over time that some of the things that we've talked about in the past are making it into that training, down to even I'm not a supervisor or anything, but individual level cyber awareness training. So we're having an effect, and that's a good thing.
Well, I think the next jump forward is that's absolutely necessary now is that once a year is not good enough in my view. It's a one and done. But and I hesitate to use this word but I think this is one where I got to use it and I have to emphasize it.
Okay.
The one and done isn't good enough. It needs to be continual training and education. And there's some really good examples out there with some of the research that we have done, as well as in partnership with some of our partners on campus through the SciLab and some of the initiatives that have come out of Carnegie Mellon, such as the Cognitive Immunity Research Collaborative Experiment, CIRCE, led by some of our colleagues from campus. Andy, I'm talking about you. It's Dr. Andy Norman. As you take a look at the psychology of learning, repetitive training and positive reinforcement for positive actions is critically important. But on the same token, you need to build up a measure of cognitive immunity so that you're not going to fall victim to that phishing or because you know what to look for.
Yeah.
So I think the repetitive but the entertaining is critically important too. And one of the great things about being part of the Carnegie Mellon community is a lot of folks outside of Carnegie Mellon don't necessarily recognize that we've got some of the greatest arts program in the world here. We, with our drama and our arts departments,
and the entertainment technology center is
absolutely
is amazing in bringing together drama, art, science, engineering.
We've got folks that build some of the greatest computer games, and recreation stuff. But we also have some of the greatest artists and entertainers. But all of that, and you pair that with our software engineering, our cybersecurity engineering, our artificial intelligence engineering capabilities, and the psychologists that we have on staff, really a powerhouse way of looking at, in the future, how do we continually update the wetware in a manner that produces those results that we want. And the results we want are an effective, efficient, and secure system that helps protect national security as well as national prosperity. So I think that one and done annual, that was the way to go 10 years ago.
Okay, all right.
And before that, I think where we need to go now is the incremental, continual, but it can't be boring, because when it's boring, you shut down. You have to see the benefit of that learning, and sometimes a little chunk is better than trying to swallow the whole whale at once.
So this may be a future podcast, as maybe getting a couple of folks out of that community with you together on a panel to talk about some of this stuff, everything from gamification to, continual learning. I think that might be something fun to do.
Well, and we've got the world's experts here at Carnegie Mellon, and when we do have that conversation, I'll be the dumbest guy in the room.
But you'll be learning, and I know that that's one of the things that you value. So, Greg, I can't thank you enough for having this conversation. We went way beyond just talking about SolarWinds, and I really appreciate, and I think our audience will appreciate the variety of topics that we were able to talk about today. So I do look forward to our next conversation, because I know there will be one, and I really I hope that our audience has gotten some ideas about how they can participate in preventing these kinds of attacks and the resulting tragedies that sometimes ensue with them. I think, as all of our podcast audience knows, we will be having lots of references in the transcripts for the different things that we've talked about. I also want to make sure that you know that this podcast is available in both audio and video form, and it is available pretty much wherever you are going to get your podcasts, from Google, Apple, SoundStitcher, all of those places that have become common, as well as, of course, the SEI's own YouTube channel. So thank you very much for listening today, and thank you again, Greg.
You're most welcome. Thank you, Suzanne.
Thanks for joining us. This episode is available where you download podcasts, including SoundCloud, Stitcher, TuneIn Radio, Google Podcasts, and Apple Podcasts. It is also available on the SEI website at sei.cmu.edu/podcasts and the SEI's YouTube channel. This copyrighted work is made available through the Software Engineering Institute, a federally funded research and development center sponsored by the U.S. Department of Defense. For more information about the SEI and this work, please visit www.sei.cmu.edu. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.